this objective, we're going to be solving radical equations. So far, we've been simplifying radical expressions, but we haven't had any radicals involving equal signs. But today we're going to start. So if we think back to our square root quiz, we have already seen some similar examples of this. So on the square root quiz, we had the square root of some number is equal to 8, and we needed to know that our perfect square was 64, or that our perfect square was, if we're finding the square root equal to 3, square root of 9 gave us 3, or for 5, the square root of 25. So how are we going from 64 to 8, from 9 to 3, from 25 to 5? What is happening to this number that's giving us that product? And we should see that it's 8 squared giving us that root, or 3 squared giving us that number, or 5 squared. So really, we can kind of work backwards and say, all right, well, I know that I'm squaring this number to get the number under the root. Well, what happens if that number is unknown? So if I go back to my example number 1, the square root of x equals 8. Okay, well, we know, because this is a perfect square, that x is 64. But what happens if it's a big number or a perfect square that I'm not familiar with? How can I get rid of this square root and get the 64? Well, I know I'm squaring my 8, and if I do something on one side, then I have to do it on the other. So I'm going to square my square root. These are inverse operations. They're going to cancel each other out, which is just going to leave me with x equals 64, which we already know is the answer because of our perfect square. But let's do something a little bit larger, like number 2. If the square root of v equals 24, well, I don't know my perfect squares that high, up to 24, so I would be stuck. But I do know that in order to get rid of the square root, I can use my inverse operation, and the opposite of square rooting is squaring it. If I do it on one side, then I do it on the other side, which is going to cancel and leave me with just my variable. And then I can type 24 to the second power in my calculator and get 576, which is a big square that I might not know by heart, but I still can figure it out by using inverse operations. So our key point here is to undo a root. You need to raise it to the power of the index of the root. Okay, so here's an example for number 3, a third root of m. Right, so again, I want to undo this third root, so I'm going to just raise it to the power of whatever my index is. So if I have the third root, then I'm going to take it to the third power. That's going to be an inverse operation, and if I do it on one side, I have to do it on the other. And 4 to the third power, just type it in your calculator, and you get 64. And you could do this with any power, even the 5th power. So if I have the 5th root of z, I'm going to raise it to that index power. So the 5th root to the 5th power is an inverse operation, and what I do on one side, I must do on the other, which leaves my variable isolated by itself, and 2 to the 5th power is 32. So now we're going to get into solving some more complex radicals. What happens when I have a step inside my radical? Well, first, I want to get rid of the radical. So we just talked about how to do that. The second step is going to be solve for x. So here, yes, I've got stuff going on under my radical that I didn't see in the first 4 examples, but that's fine. I know I want to get rid of my square root. I know that there's a hidden index of 2, which means I need to raise this to the second power. And if I do it on one side, I have to do it on the other side. So I can simplify 3 squared is 9. The square root to the second power is an inverse operation, which is just going to leave me with x minus 6. So then my second step is to solve for x, and now we just have a basic algebra problem. So I add 6 on both sides, which leaves me with 15 equal to x. And I can check my work by plugging it back in. So a quick check would be 3 is equal to the square root. Substitute 15 minus 6, and 15 minus 6 is the square root of 9, and yes, 3 does equal the square root of 9. So every single problem you do when you're solving a radical equation, you can know whether you're correct or not just by checking your work using simple substitution. Let's look at another example. Here I still have a square root. There's a bunch of stuff going on under my root. That's fine. Let's just get rid of the root first. So to undo the root, I'm going to square it and square the other side. These are going to cancel each other out. So I'm left with x over 9 equals 6 squared is 6 times 6 or 36. And then to get my x by itself, I'm solving for x just using regular GEMDAS. So if I want to undo division, I'm going to use the inverse operation, which is multiplication. And that is going to leave me with x equals 36 times 9, which is 324. So those are some examples when we have steps inside the radical or underneath the radical. We can also have steps outside the radical, and this is a little bit more like our absolute value. The very first step here is to use reverse GEMDAS to get the radical alone. So just like we wanted to get the guards away from our prison bars, we want to do the same thing here, and we can consider our radical our prison bars. We're going to use reverse GEMDAS to get that radical alone. We want everything away from the radical. Then, once we have our radical all by itself, we're going to get rid of our radical by squaring or taking it to whatever power we need to. And then the third step is going to be solve for x. So, looking at example 7, I can see I have a radical, but I also have this 3 floating in front of it. I need to use reverse GEMDAS to get it alone. So if I have GEMDAS, grouping, exponents, multiplication and division, and addition and subtraction. I want to use reverse GEMDAS, so I'm going to start at the bottom. Do I have any addition or subtraction? Yes, I'm adding 3. How can I get rid of that addition? By using the inverse operation of subtraction. 7 minus 3 is going to be 4. Then I have my square root of p. So do I have any other steps to worry about? No. Once my radical is alone, I can move on to step 2, where I need to work on getting rid of that radical. So if I have my square root, what is the inverse operation? I'm going to square both sides. So that's going to eliminate my square root. And 4 squared simplifies to 16. And my p is all by itself. So I really didn't have to solve for x in that example. And again, you can plug it in and check. 7 equals 3 plus the square root of 16. Square root of 16 is 4, which does equal 7. So it's always good to check your work and see that you're not making any mistakes. So in example number 8, again, we want to use reverse GEMDAS. I want to check. I see that I have this negative 8 out in front of my radical. And so I need to figure out, am I adding or subtracting this negative 8? No, there's really no sign in between my negative 8 and the radical, so then this is multiplication. So I don't have any addition and subtraction to worry about, but I do have multiplication. How am I going to undo multiplication? By dividing by negative 8 on both sides. So that gets rid of the negative 8. It leaves my radical by itself. and negative 8 over negative 8 is just positive 1. So now I'm on to step 2. I need to get rid of my radical. So by squaring both sides, I can undo the square root. So I have x over 3 is equal to 1 squared, which is 1. And here I do actually have to use step 3, which is solving for x. My x isn't by itself. I need to get rid of this 3. Since I'm dividing, the opposite of dividing is going to be multiplying by 3 on both sides. So my x is equal to 3. So those are two different types of solving with steps inside and solving with steps outside. So here are two examples where you can try this on your own. This is the square root of 9x plus 8 equals 14. And then number 10 is negative 20 equal to negative 10 times the square root of x. So pause the video, take a minute to try and check this on your own, and we'll be back in a second with your answer. Alright, so here we have a strange coincidence that both of them actually did work out to be 4. So if you were not able to get 4 for either 9 or 10, go back, check your work, really make sure that you're getting the radical by itself before you're undoing any radical. And if you still have questions, make sure you mark it in your notes and ask when you get back to class. There's one other type of problem, and this is solving rational exponent equations. These are kind of tricky because when you first glance at it, it doesn't look like this is a radical, so it doesn't seem like it should be in the subjective, but we did learn that we could convert rational, remember that means fractional, rational exponents to radicals. Right? So a quick reminder, the denominator actually becomes your index, and the numerator becomes the power, or the exponent. So something like x to the 1/2, we could change to be the square root. Remember, our denominator is the index, and we don't write the 2, but the square root of x to the first power equals 7. Right? Or we could also convert x to the 2/3. The denominator is going to be the index, so it would be the third root of x squared equals 100. Now that we've converted it to the radical version, it's very clear to us, oh, this is actually a radical. But to deal with our radicals this way is actually more work and kind of confusing. So there's a shortcut that you can take so that you don't have to worry about the radicals, but you do need to recognize that a fractional exponent, even though it doesn't look like it, is a radical secretly in disguise. So if we have x to the 1/2 equals 7, really I want to get rid of this 1/2. Well, if I have x to the 1/2 and I multiply that by 2 over 1, this is just going to be 1/2 times 2 over 1, which gives me 1. I get x to the first power. So if I multiply by 2 over 1 on this side, I also have to multiply by 2 over 1 on this side, which really I'm just saying 7 to the second power, since 2 over 1 is just 2. So 7 to the second power is 49. And we can just solve it that way. Same thing over here. If I have my x to the 2/3, I can just multiply the 2/3 by 3 over 2. That's going to give me 6 over 6, which is 1. So I get rid of this awkward exponent, but if I do it on this side, I also have to do it on the other side. So I multiply by 3 over 2. And this you're going to have to type into your calculator, 100 to the 3 divided by 2 power. You can just plug it right in, and it'll pop out an answer. So x is equal to 1,000. All right. So the key point here is to multiply by the reciprocal fraction to get your variable by itself. We can also see this being used in groups. And so, again, it doesn't look like we have a radical, but we should know that this 3 over 2 is actually going to be a radical. So just like we had with our radical equations, we want to use reverse GEMDAS to get exponent term alone. Since the exponent is the radical, we want to do the same thing we did before. Use reverse GEMDAS to get the radical alone, use reverse GEMDAS to get the exponent alone, and then finally we want to multiply by the reciprocal exponent, which is like undoing the radical. So an example like this, I'll write out our GEMDAS. So I have grouping, exponents, multiplication and division, and addition and subtraction. And I want to go in the reverse order. So first I need to look and think, do I have any addition and subtraction? Because I want to get this exponent group alone. So yes, I do have addition and subtraction. I have minus 6, so I'm going to add 6 to both sides. That gets rid of that. I have 3 times x minus 5 to the 3 halves power equal to 18 plus 6, which gives me 24. So now I continue checking for my reverse GEMDAS. Do I have any multiplication or division? Yes, I do. I have this 3 hanging out in front. Since there's no sign, I know that's multiplication. So to undo that, I'm going to divide by 3 on both sides. So I'm going to have the group x minus 5 to the 3 halves equal to 24 divided by 3 is 8. Now, do I have any exponents? Yes, I do have exponents, which we know are actually radicals. So we want to multiply by the reciprocal to take care of this exponent. So I'm going to multiply by 2 over 3, which is going to get 6 over 6 or 1. So my exponent's gone there. But if I do it on one side, I have to do it on the other side. And again, you can just type this into your calculator as 8 to the 2 divided by 3 power, and it should just pop the number out. So I am left with just x minus 5 equal to, and when you type that into your calculator, you get 4. And then the very last step is solve for x, so I'm going to add 5 to both sides. So I get x is equal to 9. And again, you can plug this, substitute it back into the original equation, and you should get 18 to double check that you've gotten your work correct. So lots of different types of problems in this objective. We have a quick self-check. Make sure you're going back and checking your notes to help you with this, and making any notes on places where you're getting stuck. So complete these 3 problems in your notes and be ready to discuss it when we get back to class.